Assalamu alaikum. My name is Shakib Hassan and my presentation topic is digital car parking system. Now I will discuss about why we use a digital car parking system. Due to the rapid increase in the number of vehicles, parking management has become a serious problem in modern cities. As the number of vehicles grow, finding and managing parking space become more difficult, especially in busy area. Many parking systems still operate manually, which makes them slow, insufficient, and prone to human error. Manual systems cannot provide accurate real-time information about available parking space and often casual delay and congestion. To solve this problem, digital logic circuit obtain an automated and reliable solution. By using sensor, logic gate, and counter, a car parking system can automatically detect vehicle entry and exit and display available space. To improve efficiency, reduce human effort, and ensure better parking management. The main objective of this car parking system is to automate the monitoring and management of parking space using digital logic circuit. The system is designed to accurately detect vehicle entry and exit with the help of sensor, ensuring that the vehicle movement is properly recorded. Another important objective is to continuously count the number of cars present inside the parking area using digital counter. Based on this count, the system displays the number of available parking slots in real time, helping driver make quick decisions. Additionally, when the parking area becomes full, the system automatically restricted further entry to prevent congestion and overflow. Overall, this system reduces manual work, improve accuracy, and increase efficiency in parking management. This parking management system we use a various component, and these components are IR sensor, up-down counter, comparator, display unit, control gate, and encoder. This is the overall block diagram in the parking system. Now I will explain all the component part by part how to work this component. In the car parking system, the maximum capacity have 10, so we use a 4-bit binary encoder because 3-bit encoder count 0 to 7, but the maximum capacity have 10, that's why we need a 4-bit binary encoder. The binary encoder convert the binary value from keypad numerical value. Then we use a shift register. By using a shift register SIPO, serial input data is shifted in bit by bit with each clock pulse. After all bits are received, the data become available at the parallel output. This makes it easier to process, compare, or display the data. Then we use a 4-bit comparator because the comparator compare the car. If the car equal the maximum value, then it full and it trigger the full. If the car space available, then it's trigger space available. Then we use a 555 timer. 555 timer have two parts, stable mode and monostable mode. And stable is used in timer circuit 1 because it generates continuous sequence of clock pulse without any external trigger. It has no stable state and keep oscillator between high and low state automatically. And the monostable mode we use a timer circuit 2 because it produces a single output pulse of fixed duration when triggered. It has one stable state and returned to the state automatically after the timing period. Now we use a up-down counter. An up-down counter is used to count the number of cars in the parking area by increasing or decreasing its count based on vehicle movement. When a car enters the parking area, the counter operator in up mode and increment the count by 1. When a car exits, the counter switches to down mode and decrement the count by 1. This allows the system to always maintain the correct number of cars inside the parking area. Then we use again a shift register, parallel in, parallel out. It connected to the down counter. Then we draw a flow diagram and a flow diagram operation of the car parking system in a clear and logical manner. It starts with detecting a vehicle at the entry or exit using sensor, then process the signal through the control logic based on the detection. The counter is either increment or decrement. Finally, the system updates the display and control the gate depending on the parking ability. Now, what is the advantage of the automated car parking system? Advantage is automation, accuracy, time saving, low cost, efficient parking. And where is the applicable the automated car parking system? Example: shopping mall, office, hospital, airport, smart cities. In the car parking system, there are many limitations. First of all, limitation of capacity handling. The counter is designed for a small fixed number of parking space based on my student ID digit. It becomes inefficient for parking slot with significantly higher capacity as the number of bits required for the counter increase. Then depend on 555 timer. For blinking, the system entirely on passive timing. Then power consumption. Continuous blinking for available space consume more power than need, especially when idle. Then smart control. There are no integration of intelligent decision, reverse space, sensor, fusion, timeout for car not moving, all of the limitation, and we have to some modify. The modification, first of all, multi-bit scalar counter. It used replace fixed bit counter with an n number of bit synchronous counter. Then dynamic display. Update to LCD display that allow real-time number of available space. And error correction logic. Use memory mapped 10 or shift register to control large LED or LCD display. And there are an impact of significant change. Many changes needed. This is the logic complexity increase. More logic component and control bit, counter bit. Then power and space requirement. More hardware to handle high capacity, time and synchronization must be accurate, especially in FSM and sensor design. In the conclusion, the car parking system using digital logic circuit provide an efficient and reliable solution for managing parking space. By using components such as sensor, logic gates, counter, and display unit, the system automatically monitoring vehicles entry and exit and maintain an accurate count of parked car. This reduces manual effort, minimized human error, and improve overall parking efficiency. The system also prevents overcrowding by restricting entry when the parking area is full. Therefore, this project demonstration the practical application of digital logic component in solve real-world problem and can be further enhanced using advanced technology. Thank you. Thank you, all of you, and Assalamu alaikum.